Hello, my name is Ryan Speck, and today we'll be going over conducting a simple regression. Today we'll be going over what a quick definition of a regression is, 3 different regression tests conducted using PSPP, my takeaways from using PSPP in conducting a linear regression, and of course any questions you may have at the end of the presentation. So what is a regression? A regression is a measure of the relationship between the mean value of one variable and corresponding values of the other variables. We usually refer to these as the dependent variable and independent variables. So for our first hypothesis test, the following regression was conducted where the null hypothesis, the regression coefficient beta is 0, and the alternative hypothesis is the regression coefficient beta is non-zero. A simple linear regression was conducted to determine whether individuals' debt could be predicted from income. In this case, we found no significant regression was found where beta equals negative 0.05, r squared equals 0.00, and our p-value equals 0.53, which is well above the significant level of 0.05. For our second hypothesis test, a simple linear regression was conducted to determine whether individuals' savings could be predicted from income. So we have the same null and alternative hypothesis from the previous test. And in this case, a statistically significant regression emerged where beta equals negative 0.91, r squared equals 0.82, and our p-value is 0.000, which meets our significant level below a 0.05. Thus, the test rejected the null hypothesis and predicted savings. Savings is predicted to increase as income increases. Further, the 95% confidence interval 0.09 and 0.11 does not contain 0, hence leading support to the prediction. In our third and final hypothesis test, using the same null and alternative hypothesis for beta, a simple linear regression was conducted to determine whether individual stocks could be predicted from savings. A statistically significant regression emerged where beta equals negative 0.16, r squared equals 0.07, and the p-value equals 0.00, showing that it is below the statistically significant level of 0.05. Thus, the test rejected the null hypothesis and predicted stocks value. Stock value is predicted to increase as savings increase. Further, the 95% confidence interval of 0.07 and 0.25 does not contain 0, hence lending support to the prediction. My takeaways for this presentation is that PSPP is a great tool that allows you to do quick analysis of the data set. In this case, we took the same data and imported it into PSP, and it allowed us to quickly run linear regressions and get our results. My second takeaway is that PSPP allows you to quickly summarize null and alternative hypotheses for a quick decision making on linear regression tests. Due to the ability of PSPP to spit out the results quickly, it allows me to quickly reject or accept the different hypothesis testing that we're testing at the time. From the regression test, you can determine if one dependent variable can predict the outcome of another independent variable. As you could tell from the previous 2 tests that we had statistically significant levels that you could predict various functions of income versus savings and stocks versus savings. And finally, from the regression test with the help of the constant interval, you can help prove your regression so that when you're presenting your findings to classmates, teachers, or other professionals in your industry, the confidence interval will help prove what you found. Thank you for viewing this presentation, and if you have any questions, now is the time to ask. Thank you.